Okay, so we are ripping squares out of each side of our paper. It's so close to the edge, I'm afraid it's not falling down. So everybody got squares? Now, once you've done that, I want you to take these flaps that you created and fold them up. See how I'm folding up my flaps? Now in a minute you'll see what the plan is here, but just go ahead and fold up your flaps. And then you're going to have a nice little box. Okay, so fold up your flaps. Make yourself a nice little box. Marissa, there you go. There you go. Now, Marissa is actually illustrating a perfect point. So hurry up, Luke, because you and Marissa are going to illustrate something here. Hold up your box when you get it made. All right, take a look at Marissa's box. Take a look at Luke's box. All right, or right here. Look at Ellie's and Peg's. Hold them up. Look, they started with exactly the same size sheet of paper, and they were given exactly the same directions, and yet their boxes are very different, aren't they? Look at these. Very different. What makes them different? Why are the boxes different? The size of the corners that you cut out. So depending on the size, look at you guys. Depending on the size of the corners you cut out, that will determine the size of your box, right? One of the classic problems in the calculus is to maximize the volume of the box. Here's what that means. Suppose I were a really nice teacher and I went out and bought a ton of M&Ms. And I walked around and I filled all of your boxes with M&Ms. Would all of the boxes hold exactly the same amount of M&Ms? No. Some of them are going to hold more than others, right? Well, our job is to figure out what size cutouts are going to make the very biggest box possible. That's our job. Okay? Got it? So look at your note sheets. We're on page 14, and we are going to do this problem now. All right? So we're on page 14 of our notes. Just hang on to your boxes, please. Let's not make a mess. Hang on to your boxes. We'll take care of them. Here we go. A square of side X inches is cut out of each side of a paper that is 12 by 20, 12 by 14. So this is a drawing of what you just did. And you told me correctly that the size of the corners is what's going to determine the size of the box. So you cut these out, right? And then you folded up these flaps right here, and you created your box. Now, problem number one, or the first part. Write an equation for the volume of the box. From geometry class, how do we find the volume of a rectangular solid, of a box? What's the formula? What? Well, there could be an H in it. No, there's no 1/3. What is it? Length times width times height. That's it. Now, when you start putting the 1/3 in there, that's for cones and pyramids and those weird shapes. Oh, yeah. This is just a box. So it's length times width times height. Okay? So, here we go. For our situation, the original paper was 14, but the length of the box is not 14. This is the length of the box. How long is it? It was 14. And what did you do? You took an X off this end and an X off that end. So what?
14 minus 2x.
14 minus 2x. It was 14, kids, look.
The domain.
But we're going to try, no, this is the equation. We're going to do domain in a minute. This is the equation. For this box, the length is 14 minus 2x. Now, what about the width? What's the width of this box? 12 minus 2x. Because this was 12, but we took an x off both sides. So this right here is the new width, and it is 12 minus 2x. Here's the tricky one. Look at your own box. What's the height?
X.
Very good. The height is x. Because when you fold up this flap, how tall is this flap? Isn't it x? So the formula, or the equation for the volume of the box is 14 minus 2x, 12 minus 2x times x. Now, I want you to focus your beady eyes up here for a minute. Suppose I changed the paper to 11 by 8, 8 by 11. What would change in that formula? The only thing that would change is this would be 11 minus 2x, and this would be 8 minus 2x. Every box problem you do is going to be one dimension minus 2x, another dimension minus 2x times x. Every one is going to look like that. All right, so let me go back to my original. Okay, so that's your equation. Now it says, what's the domain? So in other words, what can x be? Now, can x be all real numbers? Sometimes our domain is all real numbers. Can x be, think about what x is. X is the size of the corners that you cut out. Can these sides be any number in the whole wide world?
Yes.
Yes? So could these sides be negative 100? That doesn't even make sense, does it? So what can you tell me about x? It can't be negative, so it must be greater than 0. So x is going to have to be bigger than 0. So the lower limit for x is 0. You can't have a negative square. Right? Let's be logical. Now, is there an upper limit? Could I let x be positive 100?
Can't be more than 12.
Oh, somebody said, wait a second. X cannot be 100. Can you tear off 100 from this side and 100 from this side? Kids, the paper's only 12 wide. Can you rip off 100? No. What's the biggest you can rip off?
Less than 12.
It's got to be less than 12, but I want you to think about this for a minute. Could I take 11 off each side? Remember, you're taking it off both sides. The biggest it could be is 6. Because if it's only 12 to start with, and you're going to take one piece off each side, the biggest it could be would be 6. Now, when you do this, I want you to always go with the smallest dimension. So the 14 isn't going to be part of this conversation. We're going with the smallest dimension, which in our problem is 12, and we're going to take half of it, so we can take a piece off both sides. So go back to my paper that was 8 by 11. What would be the domain for an 8 by 11 piece of paper? It still has to be bigger than 0, always bigger than 0, but this time less than 4. because your upper limit of your domain is always going to be half of your smallest dimension. Got it? Okay. Now, the question says, find the maximum volume. So now I'm going to get out my handy dandy calculator. Graphing calculator. Get it out. If you don't have it, then find somebody who does. And you need to bring it. Or you're going to have to start renting them from me.
Is rent free?
No, it's 50 cents a period.
Really?
Yeah. You're supposed to have one. You lost your graphing calculator.
Yeah, put the 100 in there.
All right, let's open them up. Let's turn them on.
So mine's dead.
Now, we're going to put this equation in. I want you to go to y equals. Right there, that very first button, y equals. And I want you to type in exactly what I wrote. This is our y equals. I want you to type it in with the parentheses. So parentheses, 14 minus 2x parentheses, parentheses. 12 minus 2x parentheses, parentheses, x. No, do not hit graph yet. You got some work to do. Is the equation in the calculator, just like this. Now go to window. Right here is x min and x max. Your domain that you set up will always be your minimum and maximum x values. Okay? Y min is not part of your domain, but y min will always be 0 because y is volume, y is the volume, and that can't be negative. So your lower boundary for volume is going to be 0. I have no idea what the maximum is. That's what I'm supposed to be figuring out. So just type 100, a random number. Now hit graph. Now, what you must see, kids, is a picture that looks like this. You don't see that, do you? Do you have any idea why you don't see it? Because it's not high enough. You can see it going up and you can see it coming down, but you can't see the top, right? So go back to your window and try 200. Now, did 200 give you the picture?
Yeah.
Now, groupies, I want you to listen to me. The only thing that's important is that you can see the top of the hill. So could there be another number besides 200 that would work? Yes. There are lots of numbers besides 200 that could work. You need to see the top of the hill. All right? So everybody got it?
Yeah.
Okay, do you remember how to find the maximum point? We went through this before. Do you remember how to do it?
Give it to me.
How do we find the maximum point? Press second calc. Calc is in the top row of buttons, the very top row, underneath the screen. Press second calc. And then down to maximum, because that's what we're looking for. And then move your cursor so it's on the left side of the point. Hit enter. Move it so it's on the right side of the point. Hit enter. Move it so it's up to the top. Hit enter. And the maximum is the point. 2.15, 160.58. Anybody match me on that?
No.
No?
I got 2.14.
Can we go to trace for Cal?
Go to second cal.
Okay, 6 Cal.
Okay, it says you typed in your equation wrong. Oh, I see. That should be, that's only a minus sign, not an negative. It's 14 minus 2x.
Yeah, that's what she's
All right, so we're gonna talk about this and we're gonna try another one, all right? Well, you need to stay with me. Right now, stop what you're doing and pay attention, and we're gonna do another one. Here we go. The question said, find the maximum volume of the box. Every time you do this, you're going to get a point. You're going to get an X and a Y. You have to decide which one you're going to use as your answer. Remember, in the setup of the problem, X represented how big the cutouts were, and Y represented the volume. So when the question says, what's the maximum volume, you will say it is 160.58 cubic inches. That's the maximum volume. Y is your volume, X is the size of the squares. So if I gave you this paper and said, make me the biggest box that you can, you would cut out squares that were this big. This is the size of squares that will make your box the biggest. This is the actual size of the box, the volume of the box. Okay? All right, so now everybody is starting fresh, and we're starting on problem E. And we're going to do exactly what Mrs. Ford tells us to do. Because if we do that, we will all get the right answer. Okay? So here we go, problem E. Here's our piece of paper, same situation as we had before. The only difference is the paper we're starting with is 20 by 24, so it's a bigger piece of paper. And we're going to do everything we did before. Okay? So first we're going to write our equation. There should be no confusion about this. I'm even going to use V. Volume is length times width times height. So what's it going to be in this problem? 20 minus 2x times 24 minus 2x times x. Now, I graded a lot of these over the years, and sometimes kids forget this x. Don't forget it. Volume is length times width times height. Three things. Length times width times height. Make sure you have all three. That's your equation. Now, what's your domain? These are your restrictions on x. X is going to be between what and what in this problem? 0 and 10. And you can say, okay, great, I get points for that, and it's awesome. But remember, you're going to use that because this is x min and this is x max. So I'm going to go to my calculator and I'm going to press y equals right here, y equals. And I'm going to type in this equation exactly the way I have it written on the board. Y equals. Put it in exactly the way I wrote it. Now, as soon as you have that equation in, you're going to go to your window. And right here is x min and x max. And what did I tell you about y min in these problems? It's always 0. Y min is 0. Now, I have y max left over from the last one. I have 200. I'm just going to leave it 200. So y max is 200. Now I'm going to hit my graph button. Now, this is what happened, and I'm not panicking. This is what happened. Okay, what does that mean? I have to increase Y max, because what do I have to see? The top of the hill, and I don't. So back to window, I'm gonna make it 500.
I'll go to 1,000.
Yep, because 500's not big enough. So a couple of you said 1,000. All right, I'll go to 1,000. Notice, I am not panicking. I'm not freaking out. Okay, it's not big enough. I'm just gonna make it bigger. Okay, and 1,000 works. Thank you. So now when I sketch it, what I see is this. Now, that is the point I'm interested in. That is the maximum. Okay? So to find that point, I will press second calc on my calculator. We have done this before. So I'm not going to spend a ton of time. You have to see me individually if you've forgotten how. Choose maximum, because that's what I'm looking for, the high point. I could choose minimum, I could choose zero, I could choose lots of things. Choose maximum. It says left bound. Move the cursor till it's over here on this side. Press enter. Move the cursor till it's over here on this side. Press enter. Move the cursor till it's up here at the top. Press enter. And that point is 3.62, 774.16. Did anybody get that? Awesome. Making progress. Good deal. Now you need to decide, because you're always, when you do this process, you're always going to get two numbers. You're going to get an X and a Y. So you need to decide then which one answers the question. Find the maximum volume of the box. That's Y. Y is the volume. So the answer to the question is 774.16 cubic inches. That is the volume of the box. If the question were, how big do the corners have to be? You would say they have to be 3.62 inches big. Jonathan?
What if we don't have like the exact decimal?
Then you haven't done it right, because there is only one maximum and every calculator will produce it. So if you are doing second calc, you're going to get the right answer. If you're tracing, no. You have the second calc to get the maximum.
You were so childish.
Okay? All right, now we're going to do a different kind of problem. Actually, review. We did these already the other day. Look at F. Who can remember how we do problem F? I'm going to start with 52.50. That's the original price. And what's happening? What are we doing?
125.
We're taking off 25%, so we're going to lose 25%, but we have to add on 7%. Now, that means we're going to multiply by two things. Who can remember what we multiply by if we are taking away 25%? 0.75. 1 minus 25%. 100 minus 25%. Think about it like this. If you're not paying 25%, then you are paying 75%. Now, this is an add-on. I have to pay extra. What do I multiply by when I have to pay an extra 7%? 1.07. So this one was 1 minus 0.25, and this one is 1 plus 0.07, because it was an add-on. So your answer is, round it off to the nearest cent, like the store does. Did you get $42.13? That's what you would pay for this item. Now, G is the same kind of problem, but it's a little bit different. You got 2312, but what's happening? Well, you're adding on 7% for the tax, and then you are adding on another 15% for the tip. You see that? 2 add-ons this time. No discounts. So what do we multiply by when there's a 7% add-on? 1.07.
7% markup.
What do we multiply by when we have a 15% add-on? 1.15. So the total cost of my meal will be $28.45. Yep, $28.45 will be the total cost of my meal. Everybody good? I have one more problem. I want to get it started. I don't know if I'll get it finished or not. You did these problems back in first year algebra. Try to remember back in those days when you made mixtures. Do you remember having something that was, 32% acid, and you mixed it with something that was 70% acid, and you got something that was 58% acid, something like that? Remember doing those? Well, you did them, even if you don't remember. So we're going to do them again. This is the format that I want you to use. Write this down. Amount times percent plus amount times percent equals amount times percent. Now that format is simple for you to remember, and it will work every single time. So remember, in these problems, they're called mixture problems, you are mixing two things together to get a final product. Right? All right. The good news is, when you use this format, there are 6 numbers, and an amount times percent, an amount times a percent, and an amount times a percent. There are 6 numbers. 4 of them are in the problem. So tell me what's in the problem, and then I'll let you go. What's in the problem?
18, 20%.
Well, I'm on problem H. So I have a 12% lemonade. So I put that in as 0.12. I have a 20% lemonade. And I'm going to end up with an 18% lemonade. So right now, I have filled in all of my percentages. Now there's one more number that's in the problem.
18.
And where does it go? It's an amount. Which does it go with? The 20. It says you have 18 gallons or 18 gallons of that kind. All right? How much 12% lemonade? That's X. How much? X. Don't know. Gotta figure it out. As soon as you tell me what goes here, you are free. What?
X plus 18.
X plus 18. Mason just saved you guys butts. That is right. Because if you add X and 18 together, you have X plus 18. All right, we'll pick up here tomorrow. I see you tomorrow, I hope. I believe. Oh, put your boxes in the recycle, if you would, please. All your little scraps, all your little corners, put them in the recycle on your way out. God bless you all.